One of the most exciting things you can hope to witness is the launch of a giant space rocket as it heads out into outer space. This space shuttle right here is about 200 feet long, and when the countdown gets to 0, 5 rocket engines fire and they shoot out billowing clouds of smoke and flames that are bright as the sun. And by the time the sound waves roll across the Florida landscape to where you're observing from, the rocket's already traveling several hundred miles per hour. In just about 8.5 minutes, that rocket will be in space, orbiting Earth at about 17,600 miles per hour. It's a wonderful experience to be able to witness. Well, my name is Gregory Vogt, and I'm with the Baylor College of Medicine Center for Educational Outreach. And today our topic is rockets, force, and motion. And I'd like to demonstrate for you a very exciting and enjoyable activity for students and how to learn about rocketry. It's to build a rocket car. And our objective in doing this is to become a rocket scientist. We're going to build a car that's going to run in a competition among cars of other students, and the object is to make your car go the farthest. So that's really our objective right here. Before we begin, I'd like to show you a very simple demonstration you can use with the students to help them understand how their rocket car will be propelled, and also give them some ideas of how they can build their own cars and make them work really well. This is a rocket-propelled pinwheel. We're using a balloon as our rocket engine, and it's attached to a flexi straw with masking tape, and you just wrap the tape around here and squeeze it really tight. You see this is the long end of the straw, and here is the bent end. And then to hold it onto a pencil, we have a pin that goes right through the tube and into the eraser. It's real simple to work. All you have to do is to blow up the balloon through the straw. You can pinch it off like this and get ready. 3, 2, 1. And away it goes. And that's a good way to show your students how the rocket car will be propelled. But in order to do the objective, we have to understand a little bit about rocketry and force and motion. So I'm going to cover a little bit of the background and then show you just how to build the car. But first of all, let me just show you what the car looks like. It's made out of styrofoam that comes from food trays from the supermarket. It's got a couple of straws and some wheels that you made out of it, a balloon and some masking tape. Very inexpensive materials here, and you'd be surprised at how well this thing works. Well, let's find out a little bit about the principles behind rocketry, because when you launch a small rocket, or a rocket like this one right here, a small rocket, or the giant space shuttle, the principles are exactly the same, and it applies to our rocket car as well. The principles give us mission success if you understand how to use them, and that's what we're going to learn a little bit about. The principles are Isaac Newton's 3 laws of motion. And the basic knowledge behind this is, well, we've got to know a little bit about force, balance, and unbalanced, acceleration, and motion. I'll just kind of go over these real quickly using my rocket here as an example. This rocket's going to sit on the launch pad forever and ever unless we can act upon it with an unbalanced force. Now, what do I mean by that? Well, first off, the forces are balanced. That's why it's sitting still. Gravity is pulling it down. The structure of the rocket is holding it up. If I fire the rocket engine, then the force that it's produced, the exhaust of gases and so forth, comes shooting out the back. It provides a thrust that lifts the rocket off. So that's the first thing. We have to have a force. And because the force is unbalanced, means the rocket moves. If all the forces were balanced on it, it wouldn't go anywhere at all. Now, the acceleration part is, well, the more you shoot out here, the faster you shoot it out, the faster this rocket accelerates. And when you say acceleration, we're talking about changing your position over time and how fast you change your velocity, basically. And motion itself is just a change of position or an angle here. So our motion is on the launch pad, and off we go. All right. Well, here's what we're going to do. We're going to build a rocket racer taking advantage of these laws, and I'll go into more detail on the laws in just a moment. We'll set it on the floor, and we're going to use the principles of Newton. The first principle has to do with the rocket will just sit, the car will just sit there until we give it an unbalanced force. And the rest of it we'll see in just a moment here. Newton's laws of motion, by the way, were published actually in 1687 in a book which people call Principia. It has a longer Latin name than that. And it was one of the most influential science books in the history of science. But it defines 3 laws. And the laws are, well, the first one is the law of inertia. Now, we know about inertia. Inertia is that property of all objects that cause it to resist a change in motion. Well, our rocket sitting on the launch pad has inertia. It doesn't want to go anywhere until we exert that unbalanced force, which is listed in the law right here. And once we give the force, it gets going. So basically, the first law of motion is inertia. The second law of motion, though, the third law of motion we're going to jump to, is the one that's very popular and people know about this one. It's called the law of action-reaction. Basically, with a rocket here, our action is the exhaust of gases coming out the back very fast. The reaction is the rocket goes the other way. And you have examples of action-reaction in your life all the time. Every time you walk from one place to another, your legs are putting force on the ground, pushing one way, which is an action, and the reaction is your body goes the other direction. Or you're driving a car. Anytime you move, action and reaction is part of that. So that's our third law. And then we take a look at the second law, and this has to do with the real practical side of rocketry. It's a mathematical equation. Force equals mass times acceleration. This talks about the performance of the rocket. The mass is the gases that come out the back of the rocket. So you produce a force by burning the rocket fuel. The fuel shoots out the back, and it's how much gas is produced that shoots out the back. So that's our mass. The acceleration is how fast it goes out. And the bigger the mass that you shoot out the back, or the greater the mass, and the faster you accelerate it, the greater the acceleration, the more force you get. So that's that second law of motion right here. So our three laws of motion is it takes a force to get the thing going, an unbalanced force. Action, reaction, exhaust, rocket takes off, and the magnitude of the force, or the motion of the rocket, has to do with how much you shoot out the back and how fast you shoot it out. Well, that's our idea behind this. So let's see how these laws apply to the actual rocket car we're going to be building. Well, our car here does not use a rocket engine that, in fact, is a burning type engine. Instead, it has an engine which is really a balloon. So I've got another balloon right here. I'll try to inflate it here and talk a little bit about balloons as rockets. Okay, I'm not going to blow it up very far, but I've got the balloon blown up here. And we have air inside the rocket. The air is under pressure because the rubber of the balloon is squeezing on it. So this is our rocket body. You could say the nose cone is up here. And down at the bottom is the rocket engine, our little nozzle right there. When I let go of the nozzle, you know what's going to happen, of course. The air will come out, and we get an acceleration of gases. And the gas doesn't have much mass, but it has some mass. So here we go. 3, 2, 1, and off it goes. It's really a rocket. It actually really is a rocket. Well, we can use the same idea, though, to propel our rocket car. Now, the question is, how do you build a car, and what is your strategy for working with the students? Well, first off, you're going to have to get your materials, which are really not all that much. A styrofoam food tray. This is the kind that I usually see in the supermarkets used for chicken and so forth. What you can do is go to the butcher at your supermarket and ask if they can give you some trays, donate the trays to you. You could use trays that are already have been used to hold chicken, but then you've got to wash them really well. It's not worth the effort to do so. So I strongly recommend that you go out and you talk to the butcher and ask them for a donation. At the very worst, they may charge you a few cents per tray. So you get one tray for each student, or if you have students working as teams, a tray for every 2 or 3 students. It's nicer, though, to have individual ones because then everybody gets to take their rocket car home afterwards. In addition to that, you will need some straight straws. These are the ones that don't have the flexi part. You can find those in the supermarket. And then you need some coffee stirrers. Now, you want to go for a long type here for those really tall coffees. And so you got one of those. You need 2 of these and 2 of these. And then finally, you're going to need a flexi straw and some balloons and some masking tape, and then your tools are a scissors, a pencil. In fact, even you can get around without using scissors at all if you'd like. All right, well, here's what we're going to do. We're going to show you how to build this car here. So there's our materials. We're going to show you how to build the car. And by the way, the balloons you can buy from party stores. They're 4 or 5 inch in diameter. That's what the size is. You'll have to buy a bag of about 144 because they come in that size. And we're going to start by cutting out the car. Now, your food tray is all your material. Everybody gets this. They have to plan ahead. So part of the good thing about this activity is that students have to think ahead before they start cutting. You've got to build your car body, whatever shape you want it to be, and you've got to get your wheels out of the styrofoam. So if you make the car body too big, your wheels become very, very small. You have to think ahead. The wheels don't all have to be the same size. They can be different sizes. It doesn't really matter. So what you'll need to do, and I'll show you can take your scissors, and let's just show you here, you can cut this material quite easily. It cuts easily, but some kids have trouble working with scissors and may not have enough practice. So another way to cut out things, like a wheel, for example, we've already started here, is you can use a pencil, a sharp pencil, and just simply perforate the outline of your wheel like this. So I've done that now, and I can simply break this, and the wheel comes out from the plastic by just simply breaking along the perforation. So now I've got my wheel shape. And the wheel shape isn't very good shape. It's kind of rough here, but you can do things with it. For example, here's a nice big wheel. If you look at it, it's got all kinds of bumps and so forth to it. Not a very round wheel. Easy to make it round, though. All you do is set it on a hard table surface and go like this and kind of put pressure down and roll it on there. And those bumpy things that stick out, well, it's getting rounder now. It's not perfect yet, but it's gotten a whole lot rounder than it was before just by doing that. So that's our wheel right there. Well, I've got one that's already set up here with a hole in it. The next step is you take your pencil and stick a point right in the hole, and right where you put it right where the hole should be, and you punch the hole there, just large enough to fit the coffee stirrer. And all you do is stick that in like this through the hole, and if you don't make it too big, it already holds in place and looks pretty good as it is. But that wheel is going to fall off in no time, so the trick is take a small amount of tape, masking tape here, and just simply touch it to the top of the straw like this, here. Then push it down until it tapes onto the wheel. And now you've got the wheel in place, and that's real good. Now, of course, if you stick this on the bottom of the car and try to tape it there, it's not going to work so well. So what you need to do is to have part of your bearing made up here with a second straight straw, with a straight straw. I'm going to cut the straight straw like about that and slide it over the coffee stirrer. Now, you look here how easy that turns. Beautiful, smooth bearing here that we've got. Well, you take put the other wheel on the other side there, and when you have the other wheel there, then all you have to do is take it to the bottom of the car, like I've done with this one here, and tape them on. So now I've got these wheels that turn real nicely, and they're taped to the bottom. So the car will roll quite well. We're getting close to having the car made here. So we got the wheels, we've got a cutout here, we've made the wheels, there's our wheels, and we've assembled them here. So now we got to attach the rocket engine. Now the trick with the rocket engine is that you need to tape it onto the flexi straw. So the short end of the flexi straw right here is what you use. You slide the balloon, which, by the way, a good trick is have the kids pre-inflate the balloon to get it soft, because it's kind of hard to blow these up if they're brand new. Then you take your masking tape and you simply wrap it around the nozzle and tape it right to the balloon, to the straw. Just kind of roll the tape around like this. Now there's going to be leaks there, so all you got to do is squeeze it really good, and that seals up all the little holes. And now when you inflate the straw, or blow through the straw rather, you inflate the balloon. And when you let it go, the air comes shooting out. That provides your rocket thrust. So we take this and tape it to the car. And when you've done that, you've made your rocket car. So I'm going to clear off a little space right here and show you how this thing works. Get my tools out of the way. What you will do is you will take it out into the hall of, say, your classroom area, take it out in the hall. It works best on nice, smooth surfaces, but it can also work on carpet if it's not a really, really puffy type of carpet. It'll work very well on that as well. Set up a tape measure on the floor and have the kids try to go for the farthest they can get their car to roll. So I'm going to have my car here going. I'll blow it up. Set it down right here. And I'm holding the straw to keep the air inside. So here we go. 3, 2, 1. And away it goes, and it's gone. That's how you do that there. It works very well. Now, the problem is, when the kids first build these, they're going to find out that the cars may not go quite as far as they want them to, or they might turn in circles because their wheels aren't on straight. The object is you take it back into your desk and work on it again. Make it better. Try it again. Do something different. Maybe the wheels are too small. Maybe the wheels are too big. And you try different things. And go back out there and go again. And each time, if you have this tape measure on the floor, the kids can measure how far the car goes. And the performance, how well they've designed their car and built it, will be determined by how far the car goes. Now, believe me, these cars go a long way if they're made well. We've seen them go as much as 10 meters along a classroom floor. So you can get them to go quite far and have a real good competition with the kids in doing so. So this is the project right here. Build a rocket-powered car. Well, you can see this is really a a fun activity to do. Now, of course, we've got to make sure that the students understand some of the basic principles behind it. And the principles that govern how this car operates are Newton's laws of motion. There are 3 laws of motion. The first law of motion has to do, it's very simple really, that if this thing is sitting on the tabletop right now, it's going to stay there unless it is acted upon by an unbalanced force. So Newton's first law says an object in motion or object at rest will stay at rest unless acted upon by an unbalanced force. Right now the forces are imbalanced because gravity is pulling it out in the structure. The car is holding it upright. But when we inflate the balloon and we let the air come out, that produces an unbalanced force, which is not balanced by a force this direction. So what happens is the car goes that way. So that's our first law of motion. The third law of motion, which I like to jump to because it's the common one that people know about, that's action-reaction. For every action, there's an opposite but equal reaction. Well, the air comes out of the rocket engine this way here, and the car goes that way. This is the action, that is the reaction. And the second law has to do with the measuring the actual amount of forces. The force that's produced by this rocket engine is determined by 2 things. Mass times acceleration. So the equation is F equals ma. What that amounts to, very simply, is that the amount of air coming out the back here, the exhaust products here from this, the mass of that times how fast it goes out determines how much force you have. So the greater the amount of air you shoot out the back and the faster you shoot it out the back, the more force the car gets to make it propel across the table. So our 3 laws of motion takes an unbalanced force to get it going, action, reaction, and the amount of air coming out, the mass times its acceleration determines the force. Well, it's a great little project, and you can learn a lot about basic physics by building a rocket car. Well, have fun with it, and your students will really enjoy this. Good luck to you. Goodbye.